Welcome to Standard Geometry, Section 2.1. So, in this chapter, Chapter 2, we're going to start going over more of the geometric things like line segments and angles. So if you'll remember from last time, a line segment is just a piece of a line that starts and stops somewhere, like from point A to point B. So some new vocabulary, if you go exactly halfway along the line, then this is called the midpoint. It can be any letter we want. Usually we'll pick M, because M for midpoint is going to make sense. Okay. Sometimes we'll want to talk about things that go through the midpoint. So if something goes through the midpoint, M, we call it a bisector. So it can be a line segment. This line segment CD is a bisector. In fact, it's a bisector of AB. So CD is a segment bisector of AB. We could also do the ray CD that goes on forever. And CD would still be a segment bisector. So when we say segment bisector, we don't mean that CD is a segment, we mean that AB is a segment. So if you bisect the segment, you're a bisector. So anything that goes through the middle is that. It could be a plane, a ray, a line, or a segment. Okay, so what is your homework going to look like in this section? Well, most of the homework is going to involve using basic algebra to solve problems involving the midpoint. So basically every problem will show some line segment, AB, or whatever we're going to call it, and it'll show its midpoint, and it'll label the lengths of different pieces, and you have to find all the lengths that we don't know. So for instance, let's say that the entire length is 26. This is in the book. Just to give you guys a different example, I'm going to make this 14. So if you want to see the book in the example, you can. What is the length of AM and what is the length of MB? So what are the lengths AM and MB? Okay. By the way, if you write 2 points and you don't put a bar over them, that means the distance between. So just to recap that, AB is a segment, and AB without a line is a distance. Okay. Well, the whole point about midpoint is it's midway through. So that means that the other distances, like AM, the smaller distance, is going to be 1/2 of the total distance. 1/2 of 14 is 7. Okay. Here's a similar problem. Let's say that we have the midpoint, we have A and B, or let's call them a different name. It's 2 good letters. What about C and D? And feel free to pause anytime you need to for these examples. Okay, so M is going to be the midpoint, and let's say that this is 8. Then what is CM? Well, because it's the midpoint, that means that it's exactly in the middle. So the right side is half and the left side is half. So we can set these two parts together. So CM is going to equal the same thing as MD, which is the other side, which equals 8. Now some of you may be confused. You may have thought, man, when I did it, I just said CM is 8. I didn't do the middle step. That's totally fine. You don't have to do the middle step. There's usually multiple paths at arriving at the same right answer in math. It's not all about doing things exactly the same way the book does. Okay, and they have more examples in the book of this. Okay, so now let's do it with segment bisectors. This isn't really any harder. We're just practicing this now because later on, if we don't remember what a segment bisector is, we'll be confused. Okay, So let's say we have a line L that is a segment bisector. So remember, we use cursive letters for lines or 2 points. So let's say that this distance is measured in x's. I'm doing this example like the book. And this distance is something we know, like 36. And let's say L, the line L, I'm going to leave a space, I can draw it in cursive, is a segment bisector of AB, find x. Okay, and now we just need to include the symbols. We include a bar over AB because we're talking about the whole segment. We include a lowercase cursive l because that's the name of the line. Okay, because it's a segment bisector, both sides are equal because they're both exactly half, so we can set 6x equals 3x. This is a common thing we'll do throughout this class, setting two parts equal. Remember, if you want to get x by itself, you have to undo whatever's happening to it. So, since we have 6 times x, we have to do the opposite of times. And what's the opposite of times? Division. So we divide both sides by 6. And 6 over 6 is 1. It cancels out. That was the whole point. We're trying to cancel out. So if it didn't cancel out, we messed up. And 36 over 6 is 6. Did it really matter that we had the segment bisector and not just the midpoint? No. The only reason we're doing this is because later on we're going to have segment bisectors of triangles. And we're just going to assume that you remember that it cuts it right through the midpoint. Okay. So next, let's talk about the midpoint formula. Now this is a part where you're learning stuff that the people in the other class are not learning, at least not for now. They'll eventually learn it because, you know, it's like standard math. And we'll go over it in IB stuff. But, yeah, they're not getting this right now. So this is what happens if you have coordinates. The reason they're not getting it is because Greeks don't like coordinates. Okay, if this part doesn't make sense to you, it's okay. Some people struggle with abstraction, which is where you take out all the numbers. And that is just fine, as long as you figure out a way to make it work for you, eventually. So imagine you have 2 points, x1, y1, and x2, y2. If you remember, the first term is x1, and that's how far left and right things are. So you start from 0, 0, and you go to the right x1, or to the right x2. And then the second number, y1 and y2, is how high you go up. So you start from the center, you go right x1 or x2, and then you go up y1, or you go up y2. So for instance, the way I've drawn that, maybe this is the point 1, 2, maybe this is the point 4, 3. I don't know, it doesn't matter. Okay, then the midpoint M has a formula where the midpoint is, the way the book likes to write points with coordinates is it writes the letter M and the coordinates next to it. So for instance, we could have written this as the point A with coordinates x1 and x2, y2, with coordinates x1 and y1, or the point B with coordinates x2 and y2. By the way, this is all kind of dense. If you need to pause for a little bit to recollect your thoughts, that's fine. Anyway, the midpoint is going to be with formula x1 plus x2 over 2 and y1 plus y2. Okay, and so the reason this is the formula for the midpoint is because the midpoint's exactly between the two, so it's going to be the average of the two. And the way you find the average of something is you add it together and divide by 2. It's the average of the x directions, it's the average of the y directions. Okay, so let's just do a couple examples. Let's just do one example and actually be done. Let's say this was the point. A is 1, 2, and B is 4, 3. Then the midpoint would be the average of the two, which is 1 plus 5 divided by 2, which is 2.5. You can check on the calculator if you're not sure. And 2 plus 3 divided by 2, which is 2.5. So in our picture, that would be right around here. Yeah, look, 2.5, 2.5. Even though my picture's kind of bad, it still works. So if you're confused about this, I encourage you to look at the examples on page 55. But that's it for the lesson, and so thank you.